so that the last half of 6.3, guys, is we're going to learn a shortcut for long division. You might think, well, why didn't we just learn that to begin with? Because it doesn't always work. It only works in certain circumstances, okay? But it's a nice one to know, and so we'll go over it. It only works when the thing that you're dividing by is x plus a number or x minus a number. That's it. It can't be something else like x squared plus a number or anything like that. Are you looking for the notes from Monday too? Oh, thank you. That's okay. Don't worry about it. All right, but let's go ahead and get started here. So now it's like long division in that we can't have missing numbers again. So I've got a power of 3 and then a power of 1. So we're missing a power of 2 in between there. So I'm going to write that first. We got to put a 0 placeholder in there. That is still a true thing, even for synthetic. Now, so basically somebody just found that when you divide polynomials using long division with these kinds of polynomials, with binomials there, they just saw a pattern with the numbers that kind of allows you to cut out all the middle work and just kind of get right down to the nitty-gritty. So here's how they came up with it. We're going to draw an upside-down little thing like that. And what we're going to do is we're going to put the coefficients of this polynomial here, the coefficients along the top. So 5, 0, -3, and 1. Just the coefficients. And then we're going to take this guy, and we're going to take the opposite sign of that. So the opposite of -2 is a positive 2. A positive 2. And we're just going to go through a series of steps here repeatedly. So the first thing that we're going to do is we're going to bring down the 5. And we're just going to go through this repeated process of multiply, add, multiply, add, multiply, add. So it's pretty quick. So first thing we do is we multiply those. 2 times 5 is 10. And I'm going to put my answer right there. 2 times 5 is 10. Put your answer right there. Yeah. Mm-hmm. All right, and now we add down again. 0 and 10 makes 10. Then we multiply again. 2 times 10 is 20. I'm going to put that right there. And then we add again. That's going to be 17. And you multiply again. 2 times 17 is 34. And we add again. You guys might think, okay, that's fun. What was that all about? That's actually our answer there. So I'll show you how we can turn this into an answer. This piece right here is a remainder. Let's label that R. That's your remainder. So if you did long division, you would have had that number at the very end. That's your remainder. This number right here is going to be the constant of our answer. So you know how we have a polynomial plus a remainder? Well, in the polynomial, there's going to be a constant number. So that's the constant. This is an x. And this one's going to be the next power up. What comes after an x to the first power? X squared. And sometimes you'll have more. So the next one will be x cubed, next to the fourth. But there it is. So there's that. So let's label those. Now we're ready to write out our answer. We're ready to write out our answer. So we have 5x squared. 5x squared plus 10x plus 17. And I'm running out of space, so I've got to make some space. Plus 35 is my remainder over my divisor. So it's a lot nicer than long division. Much quicker. Okay. But once again, it only works for these kinds of divisors. Okay? All right. Can I delete? Yeah.
How can you tell if like this is enough W?
So that's a good question. So first of all, long division always works. On your quiz yesterday, there was a question that said use synthetic division, but I said we haven't learned it yet, just do long. It'll work. So when are you allowed to use this? When the thing you're dividing by is x plus a number, x minus a number. If you have just that, then you're good to go. If it's something else like x squared or something weird, then you have to use long division. So here's another one. Take a look right here. See that? X plus a number, I can do synthetic. All right, so let's go ahead and find guided practice. Did I print that one for you? I didn't? Oh, darn. Okay. We'll go ahead and write it down in the back. I'll wait a second for you. Write that one down in the back. I'll wait for you. All right, so let me ask Elizabeth, do we need any zero placeholders? No, we don't. We have all the terms accounted for. It goes 4, 3, 2, 1, none, so we're good. Timothy, what goes on the top row here? Uh-huh. So what would that be?
2,
Uh-huh.
9,
Uh-huh.
-20, -7, and 9.
Great. Thank you. And Bellin, what goes here? Good. -6. You do the opposite of this number here. So -6. All right, so ask Jan, I'm ready to start doing the process. What do I do first? Bring down the 2. Nice job. Let me ask Nicole, what's the next step? What do I multiply? The -6 and the 2, and we get -12. Yes. All right, and then after that, you repeat. So why don't you guys go ahead and finish up your chart there. You're going to add these together, and you're just going to repeat. -6 times -3, put it there, and so on. Kind of keep going. The 9 and the -12 make -3, and then you multiply and repeat. Yeah. Fill it in, see if you guys agree with me. If you got questions, let me know. -11, do you guys agree with that? Okay. So, Areli, what is this number? What letter am I going to write underneath? What is it? It looks like it because my handwriting's bad, but it's R. And what it stands for is a remainder. Remainder. Joshua, what's this guy right here? Martinez. Huh? Yeah. Constant. And then Jordan, what's this one? It is. And then let me ask Angel Correa, what's this guy? Squared. X squared. And then let me ask Angel Cardenas, what's this one? To the, yeah. So every time, so you start with a constant, no x, and then it's x1, x2, x3, and more if need be. And so my final answer would be 2x cubed minus 3x squared minus 2x plus 5 minus 11 over x plus 6. And that's my remainder. Once again, long division will work, it's just this is a little bit nicer. Okay? All right, and I guess I probably didn't print this one for you either, so go ahead and do that one in the back of your notes, and then we'll move on to the next lesson after that. All right, guys, so I'll put the answer up here, and you can ask me a question if you have one. But your final answer should have been 7x cubed plus 8x squared minus 3x minus 4 plus 9 over x minus 3. Okay, so 6.4 is where we're picking up today. So we're going to talk about how to find the zeros of a function. In other words, where it touches the x-axis for polynomials. A lot of this is review. There is one new concept at the end, but that part I'm not sure I'm going to get to because we're starting this lesson a little bit late, so it's finishing up 6.3. So we'll see if we get to the new stuff. But here we go. The roots of a polynomial are also known as, yes, you need one? The roots of a polynomial are also known as the zeros or the x-intercepts. It's basically the place where it touches the x-axis. What's that? I missed the whole table. Oh, my bad. So it's where it touches the x-axis. So right there in the picture, you guys can kind of see what roots are, right? And we've talked about this before. When you're on the x-axis, what we know that the y value equals what? 0. Yeah. So how are we going to find the roots? Today we're going to factor and use the zero product property. So you'll see that in some examples that come out. It's a lot like what we did when we did quadratics. Why do we care about finding the roots? Well, in this unit, we're going to eventually get to a place where we're using those to graph them. So we're going to find some key points to get a graph, and those will be one of them. So we're going to find the roots. It'll help us with graphing. All right. So that being said, let's go ahead and jump into our first example. I changed the examples from the ones that are on there, so you guys can put an X through example 1 and in student practice 1. Those two slides on your notes. I'm going to work on some other examples with you guys here. If I can. All right, so we'll call this example 1. And we'll say, find the roots. Find the roots. All right, so go ahead and write that down somewhere on a separate sheet of paper, maybe on the back if you have a little bit of space. Write that down there. And this is something we've already done this year, so it really shouldn't seem too new. We did it with quadratics, I think. All right, so as I told you guys, we're going to do this in 2 steps. Step 1 is going to be to factor. And that's the hardest step because there's a lot going on when it comes to factoring. So first of all, you want to see if you have any greatest common factors when you're factoring. So when I'm looking at this, I don't see anything that all four numbers have in common. Like 25 can only be divided by 5 or 25. And neither one of those go into these numbers. So there's no coefficient that I could take out. Also, this guy doesn't have any x's to give up, so I can't take any x's out. But we should always look for a GCF first. I just don't have one. The next thing you do is you look at how many terms there are. There's 4 terms. When there's 4 terms, do you guys remember what method to use for that? The box method. So let's do our box method. The first term goes in the top left. The last term goes in the bottom right. The other 2 go here and here. And the order doesn't really matter for the last 2. Just put them in the other 2 boxes somehow. And then what we do is we take out what they have in common in each row and each column. So for instance, in this row here, I could take out, what's the biggest number I could take out as a coefficient? 25, yeah. And how many x's? So I could take out a 25x to the 4th. In this row, the biggest thing I could take out is a 16, but you see how they're both negative? So I'm going to take out a negative 16. Going this way, 25 and 16, there's no GCF for 25 and 16, but they do have some x's in common. I can take out how many x's here? 2 x's. And here, 64 and 100. I think the biggest thing that goes into those 2 is 4. 4 does. Yeah. And you can always check your work in the end. These should multiply to make the inside, like 25 and x squared should make that. 25 and 4 should make that, and so on. And they do, so we're good. All right, so right now we have 25x to the 4th minus 16 and x squared plus 4. All right, the next thing is when there's, so box method, right? Now, these could be a difference of squares, right? This one is a difference of squares because I could take the square root of that. What the square root of 25 is 5, and the square root of x to the 4th is x squared. So the square root of 25x to the 4th is 5x squared, and the square root of 16 is 4. And you're going to write that twice. One with a plus, one with a minus. That's a difference of squares. This guy over here is not a difference of squares. It's a sum of squares, and those don't factor. Okay. Do you guys see any other differences of squares up there? The one in the middle is close, right? Because 4 has a square root, and we do have a minus, but the 5 kind of ruins it, so that's not a difference of squares. So we're going to leave it at that. Now, they said this whole thing equals 0, right? So I'm done with step 1. That's the hardest step, is the factoring. Step 2 is to use the zero product property to solve. Use the zero product property to solve, and I'll demonstrate what that is in just a second. I'm sure some of you guys are still writing, so I'll wait for you. So step 1 is all review. It's the hard step, but it's all review. GCF, box, difference of squares. Yes. Not for this, no. That's just for long. That's for division. That's a good question. Well, the only time I've given you something like this is when we've done factoring. To use factoring? No, but by then I think we'll have done enough to where you'll probably start recognizing it by then. Hopefully, we'll see. All right, let's continue. Yeah, and to answer the question further, I don't think we really have learned any ways of solving this except factoring. So, but it just kind of comes from recognition, right? Just the more practice you do, the more familiar you get with what it looks like. All right, so we had 5x squared plus 4, is that right? And then we had 5x squared minus 4. And then x squared plus 4. Okay, so zero product property tells me if these three things are multiplying together to make 0, that means any one of those could be equal to 0. So we set all three of those factors equal to 0, and we're going to solve. Okay. Let's start with this guy. Minus 4 on both sides. Divide by 5. No, you get the 5 out first. But we are going to take the square root now. So the next thing we're going to do is take a square root on both sides. And when you do that, we get a plus and a minus. What? Yeah, but we're still going to simplify this a little bit. This is not in simplified form. So when you take the square root of a fraction, you're taking the square root of the top and the bottom separately. So let's write that. Now, what's the square root of negative 4? It's not 2 or negative 2, but it's 2i. Yeah. So the negative becomes an I, and then we take the square root of 4, which is 2. So the top is going to be 2i. Oh. The bottom, though, is the square root of 5. We don't like having square roots on the bottom. What do we do about that? Multiply by the square root of 5. And you can do it on the top and the bottom. So now on the top, we're going to have plus and minus 2i root 5 over 5. Now that's done. So we'll circle that. All right, let's do the next one here. What's the first step I do? Shout it out. We'll go. Add 4 first. Good. What's the next step? Divide by 5. What's the next step? Square root. The top is? Now this time it's just 2, right? Because that's a normal 4, so we get a normal 2 out of it this time, not a 2i. And we don't like the square root on the bottom though still, so we still got to fix that. So we multiply the top and the bottom by square root of 5. Why don't you guys try solving the last one there on your own? X squared plus 4 equals 0. See what you guys get. Try that. I'll give you a second. Take a square root. The negative becomes an I. Don't forget your plus and minus. And the square root of 4 is 2. So plus and minus 2i. So we have 6 answers there. 4 of them are imaginary answers. But these are the roots. Remember, this is where it touches the x-axis. So when you have I answers there, these are not actually places where it will touch the x-axis. These are what we call imaginary roots. But it does actually touch the x-axis twice. Once at 2 square root of 5 over 5, and once at negative 2 square root of 5 over 5. So those are 2 real roots that it has. The other 4 are imaginary roots. We're still going to include them in our answer, but it doesn't actually touch the x-axis there. Okay, so step 1 is to factor. Step 2 is to set them equal to 0 and solve. Okay, why don't we do a guided practice one? Go ahead and write down this one. We'll call this guided practice 1. Find the roots. All right, so I'll give you a second to think about the first question I'll ask, and then I'll call on someone to shout. My first question is going to be, what do I do first? So, Austin, what do I do first? Okay, good. There's a lot of ways that question could have been answered. You could have just said generally factor, right? Now, when you factor, the first thing you look for is a GCF, but there is no GCF. So now Austin gave me the most specific answer possible. It's the box method. So he's right. There's no GCF. It's got 3 terms, so we're jumping into the box method. So let's do that. Isaiah, what goes here? Good, and what goes down in the bottom right? Now on this one, this is a 3-term problem. It's not like the 4 terms. When you have 4 terms, you fill in all 4 boxes, but when you have 3 terms, you only do these 2, and then we start having to guess and check. So I'm going to give you guys a second to see if you guys can find these numbers. Remember, you're looking for 2 numbers that multiply to make 3x to the 4th, and 2 numbers that multiply to make 28. At the end, you're going to complete your box and see if these add up to make the middle. Okay? These ones are the pain in the butt ones to factor, but we'll see how you guys do. So I'll give you like 2 minutes to wrestle with it, get as far as you can. We're still not done with step 1. But let me ask, yeah. Yeah, you could have had this whole thing here on the side and this one on the top. But they had to go together. So the x squared has to be with the negative 4, and the 3x squared has to be with the negative 7. Otherwise, it wouldn't work out. But yeah, so it could have been flip-flop. Maybe when you guys did it, this one was down the left side and this one's on the top. Doesn't matter. All right, so I'm going to ask Ivan, which one of these is a difference of squares? Yeah. The other one, the first one doesn't qualify because the 7 is not a nice square root, neither is the 3. So we'll leave that one alone. But I will ask Esteban, if I factored that second one using the difference of squares, what would it be? That we're factoring this guy right now. Close. So it's not 4, we went to the square root. So x plus 2 and x minus 2. There we go. now we're ready for our zero product property. Why don't you guys try solving all three of these, and we'll see how you do with that. The first one is going to be a harder one, kind of like the one I had on my example with the 5 and the 3. The last two are pretty simple. So, but go ahead and do your last step, step 2, solving for x. Factoring is done. So Max, what did you get for this one here? The middle one. -2. And this guy? +2. And how about the first one there, Max? Okay, good. So that one might have been the harder one for you guys. But first of all, if you take 3x squared minus 7, make it equal 0, you add 7 first, right? Yeah. Say that again. 2y? No, because we're not taking a square root on that one. Yeah. Next, we divide by 3. So now I've got x squared is equal to 7 over 3. Square root both sides. Now that means you're taking the square root of the top and bottom separately. Now this is where it's a little bit different because you can't find it. Like for me, I had a 4 there. The square root of 4 was a nice number, but for you guys, that's no different. But we still don't like that square root on the bottom, so we're going to multiply the top and the bottom. The bottom is going to be just 3 because the roots cancel. And on the top, since both of these are square roots, we can put those together and get 21. So this one has 4 roots. They're all real. No imaginary numbers this time. That means this polynomial touches the x-axis 4 times. Whatever it looks like, it's looping back and forth and hitting the x-axis 4 times. Once at a positive square root of 21 over 3. Once at a negative square root of 21 over 3. Another time here and another time there. So it's got 4 roots to it. All right, 4 real roots. All right, so that's pretty much it. I would encourage you guys to let's do one more, just from beginning to end without me walking you through it slowly. I'll put the answers up now so you guys can check them. You should end up with 1, 2, 3, 4, 5, 6 answers. Now notice that these are positives and negatives though, right? These are pairs. So your answers will probably look like this when you work it out. Yeah, kind of. Well, let me come to you and help you because I need people to get started here. But there's the answers. So number 3 is here at the top. We'll call that student practice 1. And see if you guys can get those 6 answers, okay? They'll be separated like the red. And then I'll come look at your paper.